Welcome to MET 211's Strength of Materials. This class is I guess you could call it an extension of a couple of your other classes and a foundation for classes you will take in the future. It's an extension of materials and statics, and it lays the foundation for many other classes, including machine elements. So it's sort of in between. It's a good class. It's a topic that it's kind of near and dear to my heart because I was actually a chemical engineer when I took this class. I took it as not this class exactly, but my mechanics of materials course I took as a chemical engineering student, and just loving mechanical stuff while all my friends were taking biology classes in chemical engineering. I could tell I didn't really fit in chemical engineering all that well. I got the grade, but was very interested. I'm glad I went through chemical. I learned a lot of good things. But anyway, so this class is particularly interesting to me because in amongst all of my chemistry and chemical engineering courses, this class was like a breath of fresh air to me. So hopefully you enjoy it as much as I did. And there's a lot to talk about here. There's a lot of really interesting stuff. And this should begin to help you think about how you prevent machines from failing. Now, some details about this class. All the lectures are going to be delivered via video, so I'm actually just making videos and putting them on YouTube and then linking them in Brightspace. So you don't have to go to YouTube and search for my videos. Just go to Brightspace and you'll find them there. And I just realized a lot of you won't know me yet. You will not have had me for class yet. So I've got an introduction video somewhere. I'll add it into this video set today. In watching the videos, I do have a due date on the videos. My main goal is that you keep up with the material. What I've found in teaching distance courses is if I don't give the students hard cutoff days for watching, or dates and times for watching the videos I post, they put it off, and they'll put it off until just before the lab and try to watch a bunch of videos, and then they don't have time, and they don't know what they're doing in the lab, and they don't end up learning anything. So I am going to have a quiz after every video set that you watch, every lecture set. And it's not a quiz that will be, a difficult concept quiz. It's just a quiz that asks you fairly simple questions, low stakes quizzes they're called, just to make sure you've watched the videos. And those will have a hard cutoff date and time. So it'll be an hour after the class ends. Now, I do have some other quizzes in the class that I use. There are 7 of them, in fact, and they're more hardcore. Did you understand the concepts? You have to spend more time. Not like a homework, but more like a concept quiz with not necessarily any calculations, but certainly some understanding of the material is required. Now, all students are welcome to attend the first class, which will be on the 25th in room 1162 at 1 p.m. As it is, our current roster does not exceed the room's capacity, even at its reduced capacity. Now, you have to be in compliance with the Protect Purdue website. In particular, you have to have the negative COVID test. If you have tried to get your COVID test finished through Purdue and they don't have it back to you yet and you don't know your status, I can't change the rules. But I will tell you that this introductory video and the other videos that I make are going to cover everything that you need for the class. So if you can't make it because you're excluded from attending classes on campus for the time being, that's okay. It's not the end of the world. So don't panic about it. Just make sure you go and watch all the videos that are assigned and take the quiz. Now, there are several laboratory exercises, and there's also projects in this class. So there's some combination of laboratory and project. For those things, often it's much better to work in lab, in person in the classroom. In fact, many of these things you can't do. For example, I doubt you have a machine for pulling material apart at home called a UTM, an ultimate tensile machine. We've got 3 of them in the back of the classroom. You have to use those machines over and over. So there's no other way except for you to come in for labs. Now, I'll try to give you about 2 weeks notice before you'll have to come into the lab and to let you know what you'll have to do. But the way I'm going to help protect you, and myself as well, and follow guidelines as closely as possible, even though the class capacity doesn't exceed the room capacity, I am going to split the class into 2 parts. So one, for the sake of labs and projects and presentations, half the class would come in on the one day, the first class day of the week, and the other half would come in on the second class day of the week. So you can see all of that here as well. Alright, now if we go into the course content, we'll start off with a syllabus. It's at the top on the left. We'll go through this first, and this shouldn't take too long. I'm not going to go through all of it in detail. Here's my office number, the meeting time for the class, the room, and so forth. As I said, all of this will be virtual except for projects and labs. And the first day, I'm sure some students will just show up wondering what's going on and what they're supposed to do. That's fine. Basically, what we're going to do is study, we're kind of going to bring together statics and materials, because a material's behavior, the way it responds to force, depends on the nature of the material, but you can kind of classify materials together. For example, metals behave differently than plastics. Obviously, that's a broad generalization, because within metals there's many different behaviors within different alloys and different, ferrous versus non-ferrous and many other things. But we're going to use these principles to understand something called stress. And stress is where you're looking at the load within the material, if you will. And from that, try to figure out what it takes to keep materials from breaking or bending or whatever it is. Or maybe we want them to break or bend at a certain amount, or a certain level of internal force. So that's really what we're looking at. You need a textbook. It's Applied Strength and Materials. I use the 5th edition, which is one edition behind. I'm trying to save you some money. Here are a couple of different ISBN numbers, so you can hopefully plug it into Google and find a good price on it. Don't worry if you don't already have the book. I always post the first couple of chapters. I'll show you where that is in just a minute. But you can already grab those chapters and download them. Now, when it comes to grading, this is probably something you care about quite a lot. There will be 12 homework sets, 10 points apiece. So it's 12% of the class grade, 10 quizzes. Now, the way the quizzes are going to work is a little different. There are 7 what I call concept quizzes, and what these quizzes are supposed to do is see if you really understand the lecture material and make you think about the lecture material a little more. These are relatively difficult quizzes. So each one of these quizzes will count as one quiz. Now that's only 7, and I promised you 10. The other 3 quiz points will come from the quizzes I already mentioned that are the lecture quizzes that just ask you if you've watched the lecture, essentially. I'm not going to ask you a question like what color shirt was I wearing in this, but I will ask you things like, direct stress is, well, I don't want to get ahead of myself, but just a simple question that you could ask easily if you had watched the lecture videos. So the last 3 quizzes will probably end up being about 24 quizzes total. So each one will account for, what is that, an eighth or so of one quiz. Whatever the math turns out to be, I'll figure it out at the end. Right now, I don't care. That's just where the last 3 quiz points and value will come from. We will have 6 labs in the class. They vary in difficulty. I'll try to warn you when a particularly difficult lab is coming up. A lot of times the last lab I actually help out with quite a bit in trying to really guide you. Let me warn you one thing about the labs, though. I have a sort of odd philosophy. I don't think that bringing you into the classroom and sitting you down in a chair and talking to you for 2 hours and then expecting you to understand works very well. And of course, you probably don't either. That's probably one of the reasons you signed up to study with us, because so much of our work is hands-on. However, I also don't believe in giving you an instruction sheet that says, okay, here's the piece of equipment, turn this knob, turn this dial, put in this sample, write down this result, run it through this formula, and tell me what this means. I don't think you learn anything doing that. Rather, what I want is to have less of a prescriptive approach to the labs and more of an exploratory approach. Some students hate this, some students love it. It is probably different from what you're used to, so just be warned about that. So I'll ask you questions like on the first lab. My question for you is there really a difference between shear stress strength and normal stress strength? Is there a difference? If so, is the relationship we have in the book reasonable or not? Go figure it out. Here's some UTMs, ask me questions, tell me what you think. And of course, I'm going to give you a lot of hints along the way. And what you should do is come to me and ask me questions, because at that point, what I'll be able to do is say, well, have you thought about this? Have you thought about that? I'll ask you questions and sort of pull you along to help you learn more in the process and then answer the questions I have in the lab for you. So these are not impossible things at all. There's many students who have gone through this class before and succeeded just fine. And I've taught the course for so long now, I've forgotten how long it is. It's probably 5-6 years now, something like that. If you're curious, I'll look it up. Anyway, projects. There are 2 in the class, and they are 100 points. That doesn't sound right. I'll have to verify. Anyway, it's 20% of your grade. The projects are a decent amount. Now, I don't necessarily I don't look at the projects as being equally difficult. The first project I think is easier than the second project. The first project is an individual project where you make what I call an adult fidget spinner. You'll understand more about what that is a little bit later. The second project is a team-based project, and some of the labs are team-based labs too, so we'll have to figure out how to work all that out this semester. There is a lot of work you can do, separated by distance, but some of the work has to be done with your hands, and so maybe you'll split that up amongst the group. I don't know. We'll figure that out. There are 3 exams in the course, and those are 10% each, so expect that to come around. Now, again, you may or may not have had a course with me, probably not at this point, so you may not understand my grading system. What I do is, at the end of the semester, I take all of your grades and I just calculate a percentage for every person. So from 0 to 100% based on how many points you've earned and the weighting of all the assignments and things that I've shown you here. And it's all according to the syllabus here. But I put the students on an increasing slope, basically, an increasing scale from lowest performer up to highest performer. So just percentages in order. And then what I do is I look for places where there are large breaks between them. So, for example, what I usually see is 3, 4, 5 students that are, well, in a usual class size, which is about 30. I'll have 3 to 5 students. They're kind of clustered together up in the high performance range. They've finished maybe 85% of the work, and well, 100% of the work usually, but maybe they got about 85% of it right. And then, those groupings are all together. Maybe one person's at 85, the other one's at 84.5, and, the lowest person there is about an 84 or so. But there's not much difference between them. And then I'll see a large break. So it goes from 82%, let's say, or whatever the number I came up with, down to about 79%. Well, that's a lot bigger jump. And so statistically, I can say, well, it's much more likely that there is a significant difference between those two groups of students. And so I feel justified in giving the upper students an A and the lower students a B, and then so on throughout the rest of the scores. So that's how I do it. Now, this makes it difficult for students to figure out what their grade will be, because if it was just a straight scale, 90 and above is an A, 80 and above is a B, and so forth, I don't do that. In fact, the worst grade you will get is a straight scale grade. Okay, a good rule of thumb, a good approximation from the past when I've taught this class, is the grades are basically just shifted down one. So a lot of times 80 to 90 is an A, 70 to 80 is a B, and so forth. So I can't promise you that, but that's a decent estimate in the way things usually go in most of my classes, in fact. All right, if there is bad weather, please watch local media for schedule modifications. I'm really not sure what else to tell you. Professor Hughes is now our director. I'm pretty sure you all know him, and he will have to make the call, and I assume that that will be broadcast out to everyone. I don't know if there will be announcements on Brightspace. If there is, I'll try to tell you. But anyway, homework is really where you learn material. Now, again, you may not be familiar with my courses. What I typically do is I assign homework, and I actually solve that homework on video for you. So you see the assignment, you see the problem numbers, you see what you're supposed to do, but you can just go right down below that in the learning module on Brightspace and see that I've got solutions for every single problem. Now, you might have just breathed a sigh of relief at that point. That's a mistake, because basically what I'm doing there is giving you a very dangerous tool. You can really hurt yourself with it, and I don't want you to, so let me warn you about it. If you sit down to do your homework, to work your homework, and you turn on my videos and just start copying, you're shooting yourself in the foot. That's a mistake. That is a huge mistake, because the homework is where you struggle with the concepts and try to apply them in an analytical way, and more of a, it forces you, rather than doing something with your hands, it forces you to just think about the principles and how they apply to a situation. It's very good for your brain, I think. I think it's very good for your understanding of the course material. Now, the reason we have a hands-on program is because we don't believe that's enough, right? So we also have the labs and projects and things. But still, that homework part is very valuable. You'll learn a lot in that process that you really won't get any other way. So don't just sit down with my videos and copy them. Rather, start each problem, or preferably start one problem, look at it. Once you get stuck, then start my video, and don't watch it all the way through. Just watch how I'm approaching the problem. What am I doing? What am I looking up from the very beginning? How do I think about this problem, because I know that all of you can go out on Chegg and find solutions to all the problems I'm going to give you, because they're all just problems out of the textbook. So you can find a solution to these problems without any effort, really. But the solutions on Chegg are not adequate. I have nothing against Chegg, really, unless you use it for cheating somehow. I think you can use it very effectively to cheat yourself. I mean, because if you go to Chegg and you just copy down homework solutions, what have you learned? Nothing. Well, maybe a little bit, but certainly not much. So I prefer that you watch my videos, and at least you'll hear me talking, and you'll hear me sort of thinking out loud and going through the problem and explaining why I'm doing what I'm doing. Not just grab this formula, plug in this number, bam, we're done, right? That's not the way that I want you to think about this course or the problems in it. Now, when you work your homework, you can turn it in to me on paper if you wish. It needs to be stapled, and I do have to quarantine it for a certain amount of time. Most students don't mess with that anymore. Most students work their problems on paper. Some do it in Excel, and you're welcome to do that too. But most students work it on paper. What they'll do then is use Cam Scanner on their phone to scan their work into a PDF file and submit the PDF file to me. That's actually the method that I prefer, and I've preferred it for a long time, not just because of our recent virus concerns. So one thing about it, though, regardless of whether you give me paper or you give me a PDF, you need to do your work on engineering paper. I will require that. I know that seems strange. Why would I require it? Well, the engineering paper is good because it helps you, it's got all the lines and it tries to help you. It's something you can use to keep yourself more organized, and that's something I struggle with this. When I was in chemical engineering, it wasn't required to use engineering paper, and I got into a bad habit of being fairly sloppy with my work. I've had to fight that, and I don't want you to get into these bad habits as well. Like I said, I was in chemical engineering. I would go over to the mechanical engineering building for a bunch of my classes, my electives and things, and I'd look at the solutions posted by the mechanical engineers, and they were always, beautiful on engineering paper, everything in its place, and looked so nice, and I was sort of jealous. I should have taken the time to develop that skill in myself, but I guess I didn't. I was too busy. So that's why I require it from you. I'm trying to help you. I'm really not trying to hurt you. Another thing about my homework assignments, I don't grade them based on you getting the right answer. So I grade them all based on your effort. If you've given me an honest try on every problem, I will give you full credit. Okay? As I said, I see the homework as your opportunity to learn. That's what it really is. So please, put effort into it, put a lot of work into it, and do your best, because it is important. In addition to the video solutions for the homework that I have, I also have solutions that I've written out by hand. So my own work, it would be as if I was working the homework myself. I do not post those before the homework is due. The videos, they're already out there. You can find them on YouTube. I've got them linked in Brightspace, and as soon as I turn on learning modules, you'll start to see that there's homework solutions in video format. I will turn on the PDF solutions afterward. Most students forget to ask for these because they've already seen the video, they already understand the homework. Where students think about this is when exam time rolls around, because they want the quick access to the PDF copies of my homework solutions for reference on the test, which I actually allow. So if I forget to turn them on, please remind me, and I'll turn on the PDF solutions as well, and you can have those for the test. Quizzes are all online, and as I already mentioned, they reinforce the lecture concepts, except for the quizzes that are just to make sure that you have essentially watched the lecture, and those quizzes are worth a lot less. All right, now one thing about the lab, not only do you have to have safety glasses, or if you wear correction you have to have side shields on your glasses, and you can't wear sunglasses. Not only that, but you also need your personal protective equipment, because we've got more labs in this class than my average, and we're going to be in lab a lot more than you may be used to. I don't know. So just be aware of that. Also, you will have to use the Boilermaker lab. If you're not checked out for using equipment there, you need to go through the process. Talk to Paul Hagman or talk to me, and I'll help you out. You can become certified to use various pieces of equipment. If you don't have a set of calipers, you should go ahead and buy one. If you're far enough along in the mechanical program, a pair of calipers is probably the most important tool that a mechanical engineer has, in my opinion, except of course for their brain. All right, what else? I am going to be more, I don't know, specific, particular about due dates than I usually am, because I won't see you in class so much, and I really am trying to keep everyone on a schedule and keep you up with the work so that you don't fall behind. To that end, I will not accept late work. So now obviously we've had all kinds of trouble with the computer system today. The students weren't able to do things on time. That's understandable. I'm not going to punish you for that, right? It's not your fault if you can't get into Brightspace. So I will work with you, especially early on, but you've got to get problems resolved so that, and I'll help you with that, I'll help you get it resolved, but you've got to get problems resolved so that we can get through the course content. We've got a abbreviated semester this year, or this time, and I still want to cover everything that you need to know when you get out of here. This is a very important class in my opinion. Of course, I guess I say that about all of them. Exams will be online. You have to be on video conference with me while you take the test. I expect you to have a camera. I expect it to be on. And we'll all take the exam at the same time. So also the final may be comprehensive. Usually it's not. But this is one of those courses that really builds on itself. So if you don't understand the difference between shear stress and normal stress by the time we get to the last exam, you might as well just take the course again. It's a very basic concept that we'll explore actually very soon in the course. I have caught students cheating in this class and others before. My punishment for that depends on how egregious the cheating was. So please don't do it. It sounds trite, but you're only cheating yourself. That is really very true, because your goal here should be to learn as much as you can. I mean, if you go to an engineering program like this and you leave it with a 4.0, you went to the wrong program. You should have went to one that was harder. It's that simple, right? There's no point in going through a program like this and not learning as much as you possibly can. And if you have a bigger, I guess I would call it appetite or capacity for knowledge than what we're giving to you, maybe you need somewhere else. I've seen a few students come through the course and I thought, boy, they really don't belong here. And it's not because they couldn't handle the work, it's because the work was just too easy for them. They were never really challenged. Now that's rare, okay? I wasn't that kind of student for sure. I don't think I would be in this program. I wouldn't be that kind of student in this program either. But I have seen some come through like that. I've seen some come through that, just struggled like crazy, but they kept at it and they worked at it, and now they have successful engineering careers. If you want to do this, you can, but don't cheat yourself out of it, okay? A more general form of that is that I expect you to develop professionalism. Professionalism is that you don't get up and make a presentation with your hands in your pockets in ripped jeans and a t-shirt, okay? If we're on a WebEx, I expect you to have a shirt on, things like that. And the reason I mention this is because I've had students do these sorts of things in classes before. A lot of your success in your career is based on things that aren't necessarily measurable. They're just impressions that people have of you. And the better impression you can give people, the better off you will be. So please try to develop professionalism in all that you do. We won't be in the class much, but when we are, there are evacuation maps and guides and things on the walls. Please do look at those as you go in, but all of you should be sophomores, so you're likely familiar with all that. If you need special arrangements in case of a building evacuation, please let me know as soon as you can. And if you get extra time on tests or you have other accommodations, please let me know as soon as you can. I need a copy of your letter so I know how much time to give you. Now, I did get one automatically from another course I'm teaching this semester. I'm not sure if they're being sent out automatically or if you still need to get me a copy. You should have a copy of it. Please do send it to me just in case. Here are the course learning objectives. Oh, and I just realized somehow this started at 3. It should be item 1, but oh well, I'll fix that later. So these are the course learning objectives. You may or may not understand what it all means right now. And here are the course learning outcomes. As you go through the class, these will probably make a little more sense. You may or may not have already seen the guidance and policies surrounding the virus, but these are just boilerplate things. You'll see these in most of your classes. I'll let you read through all of that. And then here's our tentative schedule. So this is when exams will be, what topics we're covering, what chapters we're in. So please look through this and just understand that sometimes things get pushed out a little bit. If we, I'm not the kind of teacher that wants to get through all the material for the sake of getting through the material. The reason to go through the material is so that you learn something. If you find that you're struggling and you ask your friends in the class and guess what, everybody's struggling and you really don't understand what's going on, please tell me. We can adjust the schedule a little bit and focus on some things. There was a time in one of my classes where I gave an exam and it was obvious the students just were clueless, and I said, wait a second guys, why are we pushing forward when we have this result from the exam? Let's go back, let's pick things back up, let's have some conversations and figure out what it is that you missed. I'll cover that again and then we'll continue forward. We did, and it worked out well. So my goal is that you learn, all right? Not that we follow this schedule, but typically this is a schedule that is pretty close. A lot of times we'll have 1 or 2 times when we kind of push the schedule out a little bit, but we have plenty of room for that at the end. The project is not something that should take quite this long. I think I've got 4 weeks set aside for it. It should take 2 weeks at least, maybe 3. But anyway, don't let me go too fast, I guess is what I'm saying. Make sure you're learning along the way. That's what I really want. All right, the table of contents is, if you click on it, I don't know why they have it there. I don't see it as all that useful. It's really just everything here in the list over here in a way that you really can't see all the details. So I don't have a way to remove that link, so I just leave it there. If we say start here, there is something, you can read through all this, but there's something I want to key in on. We use a lot of video. I use a lot in Brightspace by default, and especially this semester. Obviously there's going to be a lot in here. I do not recommend that you try to accomplish this course through your cell phone or your smartphone. That's just setting yourself up for failure. The smartphones just aren't flexible enough or have the interfacing needed to accomplish a course like this and to work well with Brightspace. Now there is an app for Brightspace. I think it's called Pulse. And I do recommend you get it because it'll help you remember when things are due. But beyond that, if you're trying to go through course content, I do recommend that you have a computer and a good internet connection to do it. Now, of course, you can watch the videos on your phone if you want. They are all on YouTube. You can link to them through the course website. So that might be one way to use it. But there are too many things on the course to not have a real computer or a desktop or laptop or something with a good internet connection to make it work. There's a bunch more that's sort of boilerplate stuff. I've included it. Student help and success. There's a lot of good resources here if you're having computer trouble. I did find this video and really like it. I don't require that you watch this, but this would be an hour of your time very well spent so that you can learn how to study well. This video will pay for itself many times over, so I highly recommend you take some time and watch this, but of course I don't require it. There are a lot of links for academic support. Purdue is very good about supporting you. I know we aren't on main campus, but these services and things are available to you. So make sure you know they are there, and if you need something, you can have access to it. These two are just shown down here, so no need to click on those. Accessibility information. Here are some links for people with disabilities, web accessibility, and so forth. Peruse those as you need and as you want. Some university policies that are also sort of boilerplate. Dishonesty policy, which basically says that I can do pretty much anything, including trying to kick you out of the university. But obviously we don't want to go there, right? What we want to do is we want you to take the high road and do your best and learn as much as you can, except that you're not going to learn everything in this class. You know, that's really the way it is in any engineering related program. It's like drinking from a fire hose. There's going to be things you miss, and that's normal. Don't feel like that you're somehow incapable of learning or that you aren't trying hard enough when things are just flying by you and you struggle to remember everything. I remember one of the things I really liked about going to classes was it seemed like every day, at least in one class and usually in more than one, I would learn something that I would think, wow, I never thought of that way. That's so interesting. Now, how many of those things can I quote to you now? Probably not very many of them. But part of that is that knowledge and that understanding has become a part of me. It's the way I view the world now. Whereas all my, child or young person views and thinking I understood the way the world worked are gone now. I don't really even remember them. And that's a good thing, right? I'm better for it. But anyway, so information here about various policies. Make sure you're familiar with those in case you need them. We'll go through course information next. So here's the way the book looks. Here's the ISBN number again. That price, if you pay that much for it, you've been ripped off. I think it is about a $100 book, though, last time I looked. There is a paperback version. Be careful. If you get the international version, I believe it only has metric units. I don't think that it has English units, and I think some of the charts and things are a little bit different, if I remember right. You can verify that on your own, but be a little cautious with international versions. Here are the first 4 chapters of the book, as well as the appendix and errata. You can click on these. If I center click to open it in a new window, let's see if this works. Yeah, here we go. So it's downloading the first chapter in PDF format. I think it is. I think my computer is just being slow because I'm video recording all this, and I may have just brought my computer to its knees. There we go. Okay, we're back. So all of that's available, and the reason for this is not because I'm going to give you the textbook. The reason is because you may not have ordered the textbook. You need to get it on order so it comes in by the time you run out of chapters. I do require that you have this textbook. It is a good book, and you need far more than these 4 chapters. My schedule is here. You can click on it and look at it. I am available more than what I've shown here. Now, let me show you where I'm not available. Primarily this window here in the middle of the day. My schedule with my daughter is kind of strange. It varies, and so I've decided I just want to take this hour or so from about 3:30 to about 4:30 to say, okay, I'm not available during this time any of the days because I may have to go and pick up my daughter from school, and I won't be back before 4. However, I am glad to work later than 5. If you want help, I know last semester during COVID, I helped students as late as 11 o'clock at night. Okay, this topic of mechanical engineering is something that I really like. I enjoy it, and I want you to enjoy it too. So I'm willing to get up earlier, meet with you virtually earlier, or even at the school if we need to, or work later and help you however you need. So please take advantage of that. Don't hesitate to contact me. What I'll try to do is leave WebEx open and which is our video conferencing software, and stay in my virtual room so you can just come in whenever you want. Now, if it's during a class time, especially 482 on Wednesdays, and there are other students in there, it may not be the appropriate time to come in and ask a question about strength of materials. But you can tell by just coming into the virtual room and looking around to see who all's there, whether or not you should jump into the conversation. Fridays, I assume that most of you will really not want to work late on Fridays. I typically try to start taking a break there for the weekend. Of course, Saturday and Sunday is my chance to catch up, so really it's Friday evening that I have off. But if you need time during Friday, I'll get with you. I don't mind. I've even come in on Sundays to open up the lab for students, so don't hesitate to ask me questions and contact me. There is a really nice interactive mechanics of materials site. I highly recommend that you click on this. It uses Flash, if I remember right. So I'm not sure what will happen if I can get my words out once Flash is no longer supported in Chrome, which I think is happening in December of this year. But at least we'll get through another class with it. Anyway, it's a really good site, and I actually refer to some of the individual simulators they have. And there's also some other simulators I need to look into. We may end up using some other simulators as well, but I'll post information about all that. Now, before we get into the rest of this, between course information and homework is where I will start posting learning modules. They're actually already there. I just have them off so you can't see them. The reason for that is I don't want to just kind of give you all the course content at once. I don't want to dump it all on you. That's too much. I want you to have some idea of new stuff and what you should be focusing on. So you'll see week 1, week 2, and so on. In fact, I've got 2 modules for week 1. Hopefully I'm not too long-winded on this video and I can get through all that material. But you'll see them appear here, and you should go into those and you should watch the videos and interact with those learning modules in order to learn the course concepts. Now, there will be a lot of optional videos, but there will also be required videos, and you'll have to take the quiz. Those quizzes will be in the learning modules. The homework sets are already all posted. I just post all the problem numbers, and you can see the due dates, so hopefully that doesn't overwhelm you. But homework 1 is due September 3rd, for this semester, and they're the problem numbers that you need to work. Now, they're all at the end of the chapter that I've scanned for you, so Don't panic and feel like you have to have the book tomorrow. You don't. You've got the PDF files online. What I will do also, though, is after the homework is submitted, I will post the PDF solution that I mentioned earlier so that you've got a compact form of the solution as well. Quizzes, I'm not going to turn all of those on at once. I will turn them on a little bit at a time. And these quizzes won't necessarily be one per week, although it's about one every other week or so. It's a little more frequent than that. But I will turn these on, and the idea here is that these should reinforce the lecture concepts that are presented. Laboratory is another section, and this is the first lab. It's coming up due, but don't worry, by the time you get there, you will have learned what all these things are. And there's another section I don't have on right now called projects, and once we get to the point where I'm assigning the projects, I'll turn that section on where you can see it. But for right now, just remember that the course learning modules are going to appear between course information and homework. So that's everything I wanted to show you in the class for now. By the time you see this video, there should be a learning module turned on that you can start going through. Now, it may take me a little bit longer. I still have to record the videos for it, but it's just basically the PowerPoint presentation of me talking over the slides so that you can learn the material. So I hope we have a good semester. Please don't hesitate to contact me. Don't hesitate to ask questions. I really enjoy interacting with students, and one of the things I'm really going to miss is not being in class with you guys so much. So let's try to change that. Let's try to learn as much as we can about the course, and I'm trying to learn about virtual education because, really does it make sense to ask students to drive to campus every day? I know some of you guys drive an hour away. That's a long distance. It's a lot of times, a lot of gas money. It doesn't make a lot of sense if there are things that you can learn online. Now, I don't want this class to be something where you feel like, oh, that was a horrible class because it was online. Now, along the way, there may be things that don't go well, but if you don't tell me during the class and give me feedback during the semester, I can't change anything for you. I always solicit your feedback at the end of the semester so that I can change it for the next group. But help yourself out. I'm not the kind of person that's very sensitive about things. You'll have a hard time offending me. So, I prefer that you don't swear at me. That would come under not being professional, right? But also, don't contact me and say, hey, teach, or hey, say Professor Sisk, and I'll address you as Mr., Miss, whatever. But try to develop your professionalism, but don't hesitate to be assertive with me and say, hey, I didn't understand this. If you'd said it this way, I would have understood it. Or, hey, I didn't have time to finish this because you didn't post it in time. Don't be shy with that sort of thing. That's fine. I am not going to punish you in your grade for that. In fact, I will appreciate it. If you give me a pat on the back and say, hey, you did a great job, well, that's nice. But what good does it do you or me or anyone that goes through the class in the future? If you tell me, you know what, I'm really upset because I wanted to learn this and I don't feel like I learned it as well as I could have. If you had just done this, I could have learned it better. That's helpful. That's something I would really appreciate. All right, so let's have a good semester, and I'll hopefully meet you guys in class and meet you face-to-face at least a couple times throughout the semester, certainly in the labs and so forth, and I look forward to it.